Good morning everyone, I am Josna. Today I am going to explain about VHDL programming fundamentals. First VHDL. VHDL stands for VHSIC HDL. It is a hardware language. VHSIC stands for Very High Speed Integrated Circuit Hardware Description Language. It is only used for the digital ICs and not for the analog ICs. And VHDL uses gate level design abstraction. The history of VHDL is developed by the Department of Defense in USA in 1980. 1980 to 87 they were used in Department of Defense. After 1987, Department of Defense permitted for the commercial purpose and they got the IEEE standard. In 1993, the revised edition came, but it's not synthesizable in that period. In 1996, they revised further, but it is synthesizable language and simulation tools were added. The comparison of VHDL to C language is, VHDL is a concurrent language and C is a sequential language. Concurrency means the output state depends upon the input state. Input variables changes, then it will affect on the output variable. And VHDL is a synthesizable but C is a not. The capabilities of VHDL is, it is a case insensitive and VHDL is a vendor independent. We can use Xilinx platform, Altera, Model Sim, extra. But in our program, I am going to give the examples in Xilinx platform. We are going to implement in the Xilinx platform. It supports the synthesis and it supports simulation. In absence of real system also, we can simulate these functions by taking the model of that function. And it supports the 9-value logic system. 0, 1, L, H, Z, W, U, X, hyphen. 0 means it is strong 0 and 1 implies strong 1. L implies weak 0. H implies weak 1. Z implies high impedance. W implies low impedance. U implies uninitialized. X implies foreign unknown. This hyphen implies don't care condition. And the programming structure of the VHDL is mainly 3 sections. First one is library, second one is entity, third one is architecture. Library IEEE. Use IEEE.std_logic_1164.r. These are the first 2 lines of the VHDL program. Here library IEEE means we are using the IEEE library files. And use std_logic_1164 means this package we are using in our program. .all represents this complete package, all functions we can use in our program. Next, second one is entity. Entity is a building block which is used to declare the input and output ports. To declare input output ports, we are using the entity. Entity ABCD is. This is the example how to define the entity. Entity ABCD means that ABCD is the name of my entity. See here, for example, I am considering 2 input ports, 1 output port. So AB are my input ports, C is my output port. So A hyphen in std_logic. B assigned to in std_logic means in represents the input ports. C assigned out of std_logic means C is the output port in my entity. So and ABCD. In this way, this is why we are declaring the entity. This is the example how to declare the entity. We can declare the ports according to our design implementation. Next one, architecture. This is the last and third part of the VHDL program. In this part, we are writing the logic of the program. This is the example for the architecture. Architecture, my ABCD of ABCD is nothing but this my ABCD is the name of the architecture. Begin, output less than or equal to means implies, its output is implies to input 1 and input 2. We are performing the AND operation between input 1 and input 2. And my ABCD, this is the ending of the architecture. This is a simple example, one equation formula of the architecture. So note nothing here, the important keynote is one entity has n number of architectures. We can implement many number of architectures with one entity. Next, types of modeling styles in VHDL. How many modeling styles means 4 modeling styles. Data flow modeling, nothing but we are designing the equations in data flow modeling. Behavioral modeling means we are explain that behavioral means logics. We are writing the logic in behavioral modeling. Structural modeling, nothing but connection of the sub modules we are using here. Hybrid modeling. Hybrid modeling means combination of any above 3, any 2 of above 3. We can build as a hybrid modeling. In these 4 ways we can write the VHDL programming. This is the brief introduction of the VHDL programming. I hope you can understand. Thank you.